random variables, one of the first of many random variables that we're going to be talking about today. Now, we use that word discrete like the first week of class. I already forgot what it means. What does it mean?
Discrete, that's the whole numbers.
Whole numbers, okay? So discrete means whole numbers, okay? So let's talk about a random variable. Variable, okay? A random variable is a numerical measure of a probability experiment. Okay? It's typically denoted by a capital letter such as X or Y. Okay? So typically what you're going to see is you're going to say, well, I want to know the probability that random variable X equals little x. Okay? So this big X indicates that's your random variable. Okay? The little x represents some sort of a number like 2, 3, 4, etc. Whatever the number you want to put there. Okay? So that's kind of the notation. So you'll see that a lot. Probability that x equals x, and you're like, what? Okay? Does that make sense? Capital letter represents your random variable. Okay, so let me ask you a few questions. Just to review on discrete and continuous. The number of A's that I give in this class, is that discrete or continuous?
Discrete.
That would be discrete. That would be 1, right?
0.
Or 3 maybe. Or 28. That's what we're rooting for, right? 28 A's, right? Okay, how about the number of cars in a McDonald's drive-through?
Discrete.
That would be discrete as well, okay? Probably a lot more than the number of A's we'll get in this class, right? Okay? How about the speed of a car? That would be continuous. Wait a minute, what if I go 55 miles an hour? Isn't that a whole number?
55.1.
No, it's a rounded number, 55.1 or something, okay? All right, so remember the difference with discrete versus continuous. This test is going to be on discrete random variables. I'm going to save continuous random variables for next test. Okay? So that's coming down the pike. All right, so let's just do a couple of rules, probability rules. You should know these. I think you will. They're nice and easy, but just to review, rule number 1, if I add up the sum of all the probabilities, that should equal 1. And all of your probabilities should be between what? 0 and 1. Okay? All right. So let's do an example here. You ask a basketball player to shoot 3 free throws and record the number of makes. Okay? All right, so the first question I have, what is your sample space? How many possibilities of baskets can she make? What's that? 3, she can make all 3. 0, 1, 2, and 3. Okay? So 0 is the one that most often gets forgotten. Okay? So don't forget she could miss all 3 of them. Okay? We're talking about Shamika Holtzclaw. Okay? Any WNBA fans here? Brittany Griner? Am I the only person that can name a female basketball player?
Is that a sport?
What?
I said, is that a sport?
Is that a sport? He wants to get piled on it. Okay?
I'm sorry.
All right. Okay, so here's our sample space. Now, what I can do is I would call that my random variable x, right? So x equals lowercase x. So x would equal 0, x would equal 1, 2, or 3. Does that make sense? Okay? All right, so we conduct our experiment. We find out that Shamiqua holds claw. She's a better shooter than Shaq. She misses all three only 1% of the time. She makes 1 out of 3 10% of the time. She makes 2 out of 3 38% of the time. And she makes all 3 baskets more than half the time. She's definitely not Shaq. Okay? All right. So my next question would be, okay, we did this experiment. What is the expected number she makes out of 3? Okay? Now when you think of expected number, what does that, what term should pop into your mind?
Would it be a mean?
A mean, and he didn't even use the A word, like my other class. That was good. He must have been warned. Okay, very good. So we would talk about the mean, okay? So anytime you hear the expected value, think mean. Mean. Okay? All right. So I got to give you a formula for that, don't I? Okay, so here's your formula for your expected value. It's the sum of x times the probability of x. Okay? We're going to set that equal to either mu or x bar, as the case may be. I didn't say whether this was a sample or a population. We'll assume it's a population for now. Okay? All right, so if I do this, okay, what is this formula telling me to do, Marissa?
I'm going to take your numbers, so is that your probabilities, or your
Yeah.
sample space?
You can take your sample space here,
Your sample space,
And we're
you're
going
gonna
to
multiply it by your probabilities, and
probability,
then take the
okay?
sum.
So I'm going to get the product here. Okay, so 0 times 0.01 is 0. I can do that one in my head. And 1 times 0.1 is 0.1. I can do that one too. And 2 times 0.38 is 0.76. And 3 times 1.51 is, or times 0.51 is 1.53. Okay? Now what's it telling me to do? Add them up. Okay? 6 and 3 is 9, 7 and 5 is 12, and 1 is 13. Carry the 1. 1 and 1 is 2. Okay? So I would say we would expect Shamiqua Holtzclaw to make 2.39 out of 3 shots. Does that sound like a reasonable answer? I got a lot of shaking the head. Why not? Because what? You can't make part of a shot. But let's think about this for a minute. How many children does the average American have?
2.5.
2.5. You can't have a child, right? But can your mean be a continuous number? So that's okay. Okay? So yes, we are using a discrete here, but your mean can be continuous. That's okay. Okay? It's just a mean. Okay? Does that make sense? All right. So the next thing we should do is we should create a probability histogram. I should have asked Jared to do it, but he just walked out of the room. I'll have to ask Bailey, who was sitting next to him. Bailey, how would you make a histogram? What?
Use Excel.
Use Excel. That's a good idea. We probably should turn Excel on. Okay. So then what should I do? I can't hear you. Enter my data, so I've got shots made, 0, 1, 2, and 3, and probability of x, and I'll double click that under 0.01, 0.1, 0.38, and 0.51. Okay? Now, one of the things we didn't check, how do we know this is even a legitimate probability? Should add up to 1. Let's double check that. I'm scared there. Okay? We did add up to 1. I'm good. Now, for those of you who want to be an Excel fancy pants person, okay, let me show you some cool stuff. If I highlight all my data, and I say, you know what, I want to center that so that it looks better. Okay? Not only that, I want it to have boxes around it, so I'm going to put boxes around it. How about that? Okay? I am Mr. Fancy Pants. Okay? Alright, so now, Bailey, what would I do next? Okay, should I have my sum in there? That would be a bad idea. Okay, so we're just going to highlight this. Okay, and then insert.
And then the drop-down thing.
This thing here?
No, the thing next to it.
Oh, the thing next to it. Because, let me just show you this. My last class said, oh, you guys just do a histogram. Does that look like a sucky histogram or what? Yeah, that's horrible. Okay, it'll do it, but it looks terrible. It's not what I want. Don't do it. Okay? We're going to delete that because Bailey's smarter than that. She's going to go over here. Is that what you told me to click on?
Yeah.
Okay. And then what?
Click on the paragraphs.
Which one?
The 2D column one.
2D column one. Okay. What do you think? Does that look okay? No? What's wrong with it?
Has 2 bars for each.
2 bars, right? Now I thought you were going to say my last class, so you're smarter than my last class. My last class said, oh, you got to make the bars touch, which you can do with quick layout, right? With my stupid mouse remote. So you click on quick layout, you go to there, and the bars touch. It's still wrong. Okay, you're only supposed to have one color. It could be red or it could be blue. I don't care what the color is, but it only should be one. Okay? Prefer red because I don't like blue white. Okay? Skylar, we'll let him in the class anyway. But, okay? So, what's wrong? What's going on here? Cassie?
They graph the shots and they run
They graph the shots. So I've got whole numbers here, 1, 2, 3, and actually 0. Notice here, this should say 0, 1, 2, 3, not 1, 2, 3, 4. That's another problem. Okay? So you're graphing the discrete numbers along with the continuous number probabilities. Okay? So that's what's wrong. So how do I fix that? Ashley?
Go to inserts. I clicked on recommended graphs, and then I clicked the second one. After that, I went to
Oh wow, I didn't know you could do that.
and then after that, I went to quick layout change and made it so that they touched.
Oh, that's kind of cool. I didn't know about that feature. You know what I would have told you if you didn't know about that? Because I didn't know about that. So Ashley taught me something today. She should get an extra point on her quiz. Huh?
Yes.
Okay, email me if I forget.
Okay.
Okay? All right, so what would I have said, because I didn't know about that until just literally 30 seconds ago?
When you put all the shots where you like that.
You put an apostrophe? Very good. That's what I would have told you. Put an apostrophe in front of those. Okay? Then I would have said, did the same thing that Bailey did, insert, bar chart, 2D column. Then I go to my quick layout, and I go there. Okay? All right, so now, is that a good graph? Clara? What do you think? No? Because? titles. What are you showing me, Miss Clara? What?
Oh, shots.
Shots made. And what about this? Probability or proportion, either one will be fine. Okay. What about up here? Probability and probability. Probability of shots made, I would say out of 3, because it would be nice to know that they're only shooting 3 shots. Okay? All right. Now, slide that out of the way. Now let me show you something that's pretty cool about Excel. Okay, we're going to redo this just to make sure I did the math right, but I think I did. Okay, I want to find my product here. Okay, and technically I'm taking a number and I'm multiplying it by a text. Excel's smart enough that that actually works. Okay, and then I add them up. Get 2.39 just like I did. Now typically, like if I had a word here, and I tried to multiply that by 0.01, it would say, hey, that's a problem. But Excel sometimes is pretty smart. In this case it was. Okay? So that works out to be my mean. Okay? Alright. So, if I know my mean, what else do you think I should be able to figure out? Standard deviation. Okay? So, here's my formula I'm going to give to you. I'm going to actually give it to you as the variance though. Sigma squared of x equals the sum of x minus mu squared times the probability of x. Okay, that's one formula. Or the sum, I could also say sigma squared equals the sum of x squared times the probability of x minus mu squared. Okay? Either formula should work. Okay? We're going to try to do it both ways. Let's see if we can get it. Okay? Alright. So, oh, and by the way, before I do that, what if I asked you to write that mean on your graph? How would you do that? What's that? Add a line? Okay, so I don't remember, did I show you this yesterday? Okay, so if I try to insert a line here, insert shape, I think I showed Amanda. So between 2 and 3, it's probably about right there. Okay, and I do want to show you something. Oh, Amanda was in my other class. Now, look here, if I move my graph, notice my line stayed there. Not even on the graph anymore, that's kind of annoying. Not that that's a huge deal, but if I wanted to, if you select your graph first, and then you insert your shape, you draw your line about right here. Now when you move it, it moves with you. So that's kind of cool. Okay? So it becomes part of the graph. Not a huge deal, but just, you know, one thing. Now, there could be a way to actually insert text. I couldn't see it. See if I can find it here. I don't see it. So what you do is if you click off the graph, you go to insert, you grab a text box, and then you can say that the mean is 2.39. Once again, the problem is, because I did it that way, if I move my graph, it doesn't move with you, but that's okay. I'll just put where it should be. Okay? Does that make sense? All right. Okay, so we're going back to, I've given you the variance. How would I find the standard deviation? Take the square root of that. Okay, so we're going to try this first formula first. Okay? So in this case, it says x minus mu squared. Okay, so x minus mu squared. Okay? So if I take my x, 0, I'm going to subtract subtract, oh, I should use a parenthesis there. 0 minus my mean, I'm gonna F4 that because I don't want that number changing. I'm gonna raise that to the second power. Okay? And then I'm gonna copy that formula down. Okay? And I'm gonna take that and I'm gonna multiply that times the probability of x. Times the probability of x. Okay? I'm gonna take this number, I'm gonna multiply it by this probability. And I'm gonna copy that down. Okay? That make sense? Then I'm going to do what? I'm going to do the sum. Sum of this column here. What is this value called? That's called my variance. Okay. How do I find my standard deviation? Square root equals the square root of that. That is my standard deviation. Now, does that seem reasonable? If she's making about 2.39 shots, her standard deviation should be less than 1 shot. If it was more than 1 shot, she'd already be making 4, right? Okay, so that seems like a reasonable number. Now, some of you may say, oh, I'm just going to use the standard deviation formula. Maybe you'll say, well, I'm just going to take the standard deviation of that. That's the wrong answer. And so you say, well, maybe I'll just do the standard deviation of that. Once again, that's the wrong answer. Okay? There is no cheater method for this. You have to do it the hard way. Okay? Now, I will give you another option. If you like this formula better, hopefully we're going to get the same answer. Okay? So here we're going to try it again. This is going to do my x squared, right? So if I take my x, 0, and I square that, it's still 0. Okay? 0 squared, do the others. 1, 4, 9, those numbers make sense. Now I'm going to multiply that times the probability of x. Okay? I'm going to take that number and multiply it by this probability. That's going to give me still 0. But I'll get numbers for those others. Okay? This is telling me, add them up. So if I add them up, I get 6.21. Okay? I'm going to take this number and I'm going to subtract the mean squared. So I'm going to subtract mu squared. Okay? So I'm going to take 6.21. I'm going to subtract this mean, and I'm going to raise it to the second power. Okay? What value does that give me? Variance. How do I get my standard deviation? Square root of the variance. And look at that. It didn't matter which method I used, I got it either way. Okay? All right, one last thing I want to do really quickly. Let's say that, going back here to this, I just want you to recognize these don't always have to be positive. Let's say that an insurance company pays $250,000 if someone dies, and they collect $350 premium each year. What is the expected profit? Okay, these might not be discrete numbers, but it will work the same way. Okay, your x, your p of x. Okay, let's say you collect $350, and the chance of someone living through the year is 0.998936. The chance of someone dying is 0.001064. Okay, and you're gonna pay out a negative $249,650, because you already collected the premium, okay? You can use this same method, and hopefully you can figure out how much profit or loss you'll make. You will make a profit, I didn't write the answer on there, and we're out of time, so. Anyway, just want you to know that these do not necessarily have to be positive numbers, okay? Quiz Monday on 6.1. See you, have a great weekend.
So you find out if you make a profit or loss by finding
You
the
multiply
expense.
these together,
Okay.
add them up, and positive number you make a profit, negative number you make a loss.